In the past, it was often assumed that moons were lifeless celestial bodies. As we now know, however, these constant companions of planets sometimes contain more life than we'd ever have dared to believe. One of the most breathtaking and spectacular natural satellites is Titan. As many of you probably already know, the surface of Saturn's natural satellite is not only covered by a thick layer of methane hydrate and water ice, but also by countless rivers and lakes of liquid ethane and methane. And it is precisely these fascinating natural formations that we'd like to examine more closely with you today. We'll take a look at how these breathtaking formations come into being, what role they play in the natural processes of Titan, and what different forms the unique methane lakes on Saturn's moon take. We hope you enjoy this exciting topic. Want to see more interesting videos about the most breathtaking discoveries and phenomena in space? Then subscribe to Simply Space and never miss one of our videos again. If you like the content of our posts, show us with a thumbs up. Titan's unique nature. That Titan is a very special satellite becomes clear when we take a close look at the nature of Saturn's moon. By this, we mean not only the surface characteristics of the satellite mentioned at the beginning, but also its gas envelope. In fact, apart from Titan, we know of no other moon in our solar system that has a dense atmosphere. Titan's surrounding protective gas shell is 5 times denser than the Earth's atmosphere. Specifically, the gas envelope on the moon is mainly composed of nitrogen, hydrocarbons, and a small amount of organic compounds. The closer we move from the atmosphere towards the moon's surface, the clearer it becomes why Titan is classified as an icy moon. The areas adorned by frozen materials are at least as impressive as the unique liquid methane collections, which we will look at in more detail later. The moon, whose name has its roots in Greek mythology, was discovered as early as 1655 when the Dutch explorer Christian Huygens was responsible for the discovery of Saturn's largest satellite. That this name seems extremely familiar to you is no coincidence. After all, a space probe of the groundbreaking Cassini-Huygens mission was named after the famous astronomer. The successful completion of this large-scale space project revolutionized our knowledge of Titan and Saturn's complex ring system. On January 14, 2005, the time had finally come. Huygens had detached from Cassini 20 days earlier, making the spacecraft the first man-made object to enter the atmosphere of Saturn's moon. A few hours later, Huygens landed safely on the surface of the natural satellite and sent important data about Titan back home for a good 70 minutes. These groundbreaking findings were ultimately supplemented by dozens of Cassini flybys, which took a closer look at the moon from a somewhat greater distance. Whereas the previous flybys of the Voyager spacecraft had only drawn a rough picture of the astounding satellite due to the technology of the time, scientists enjoyed an unprecedented, detailed treasure trove of information about Saturn's largest moon during the Cassini-Huygens mission, which was to last until 2017. In the course of the previous research, methane lakes on Titan were thought to form exclusively in the moon's polar regions. Today, we know that the formations also extend along the line that corresponds to the tropical latitudes on Earth. Methane lakes on Saturn's moon. Indeed, Titan is the celestial body in our planetary system that is most similar to our Earth in terms of its surface formations, even though the outer shell of the moon is known to be composed of completely different chemical compounds than the surface of the Earth. The Cassini-Huygens mission brought the realization that the moon is covered by countless lakes, rivers, and even smaller seas of liquid methane and ethane. To see how these features appear in reality, it helps to look at the colored radar image of the methane lakes that Cassini made in 2006. The dark formations stretch across the icy surface of the satellite like an endless patchwork. The fact that the methane on Titan can exist in liquid form at all is due to the bitterly cold temperatures that prevail on the moon. The thermometer on the icy moon climbs on average to just -310 degrees Fahrenheit. Experts assume that the methane on the satellite has about the same importance as water on Earth. Thus, the influence of the chemical compound is not least responsible for the external shape of the icy moon, as its natural properties are responsible for the formation of the fascinating landscape structures from frozen water ice particles. If we take a look at the methane cycle, we can find amazing parallels to water circulation on Earth. Just as on our blue home planet, simple hydrocarbon compounds rise into the moon's atmosphere, where they then rain down onto the surface and accumulate in large depressions as liquid accumulations. This is also how the complex methane flux network on the satellite is fed, with the individual flux arms practically eating into the outer shell of the moon and forming hilly areas. From a purely optical point of view, the liquid methane accumulations on Titan hardly seem to differ from the waters on our terrestrial home. The liquids are present in an amazingly transparent form. Just how gigantic the dimensions of these galactic formations really are becomes clear to us when we take a look at the 3 largest methane lakes on Titan. These have been christened Krakenmeer, Ligiameer, and Pungameer. Krakenmeer alone covers an area of about 154,000 square miles. By comparison, the largest terrestrial lake, the Caspian Sea, covers only 149,190 square miles. While we currently have to make do with post-colored radar images of the gigantic object, NASA and ESA are already making big plans to study Krakenmeer at close range in the future. As part of the tandem mission planned for the future, a lander is to come to rest on the surface of the methane lake and study its exact nature and depth. Breathtaking natural spectacles. The methane accumulations on Saturn's moon sometimes differ significantly from one another. For example, lakes located in the moon's eastern reaches present themselves as extensive, nearly ocean-like objects surrounded by shallow shoreline regions. However, if we move to more western areas, we encounter hundreds of smaller methane lakes, often located on high ground with no direct methane inflow. As shown, the largest methane lakes on Titan extend to gigantic dimensions. However, their smaller counterparts are rarely wider than a half mile, and at the same time they are graced by steep outer walls. The lakes, located in tropical latitudes of the moon, are fed primarily by underground rivers. The methane waters, again located in colder areas, derive their chemical supplies primarily from methane rain from the atmosphere. The amount and frequency of precipitation, like its terrestrial counterpart, is strongly influenced by seasonal variations. While it's known that the Earth needs about 365 days to completely orbit the Sun, Saturn, and thus also Titan, require significantly more time for this undertaking. It takes 30 Earth years before the iconic ring planet has rotated once around the central fixed star of our solar system. Therefore, a season on Titan does not last 3 months like on our blue home planet, but a stunning 8 years. Depending on the spatial position of the moon in relation to the sun, huge amounts of methane evaporate from its surface, whereupon they form thick cloud layers, which subsequently drift towards the polar regions and rain down there. The newly fed methane lakes then shine in full splendor and reflect the sun's rays in a sparkling spectacle. In the course of seasonal temperature fluctuations, we can observe another amazing phenomenon in the methane lakes on Saturn's moon. The liquid hydrocarbon accumulations throw bubbles. Experts came to this conclusion when they studied the methane lakes in a theoretical model. According to this model, nitrogen repeatedly dissolves in the lakes at a certain time of the year, whereupon it bubbles to the surface. These nitrogen bubbles are so numerous that on some radar images, they appear like countless small islands in the middle of the methane lakes. That there could actually be something like islands of solid compounds in the lake formations is actually also thought to be in the realm of possibility. Thus, solid ice flows of hydrocarbons are thought to float above all on those liquid formations that are relatively poor in ethane. Perplexing differences in composition. Experts only learned a few years ago that the methane lakes differ clearly from each other in chemical composition. An examination of some of the data transmitted by Cassini ultimately revealed that the lakes in the southern hemisphere consist of a balanced ratio of methane and ethane. However, in all probability, the formations in the northern hemisphere are composed almost exclusively of methane. What causes these differences in detail will have to be determined in the course of future research. At the same time, experts found that the smaller lakes, located on the high plateaus, are much deeper than initially thought. According to the findings, these comparatively small formations can protrude up to 300 feet into the subsurface. Is there anything about the methane lakes on Titan that particularly amazed you? We're looking forward to reading your feedback in the comments. Now click on one of the images in the credits to go to more exciting posts. Thanks a lot for watching. Take care, and we'll see you next time.